We've been talking about ellipses in section 7.3, and now we're going to do our first example. So this one says, find an equation of an ellipse with a center at the origin, a focus at -3, 0, and a vertex at 5, 0. Plot the points given on the graph below, which axis is the major axis, and justify. So let's plot the points. The origin is our center. I'll label that with a C. One focus is at -3, 0. We'll call that focus 1. And we have a vertex at 5, 0. So we'll call that vertex 2. We know, because of the symmetry, that the other focus is going to be at 3, 0 because of the symmetry, like I said. Same thing with the other vertex. It is going to be at -5, 0, again because of the symmetry. Okay, which axis then is the major axis? Well, the x-axis has to be the major axis. And that's because the major axis always has the vertices, the foci, and the center on it. So, again, the x-axis is the major axis because the center, foci, and vertices are on the x-axis. Okay, that means since our x-axis is the major axis, that our equation of the ellipse is of the form x squared over a squared plus y squared over b squared equals 1. A represents the distance from the center to the vertex, and that's from the center to either vertex. And in this case, how far is that? Well, let's just count. 1, 2, 3, 4, 5. So A is equal to 5. C represents the distance from the center to either focus, and in this case it's 3. We can count that. And we find B by doing B squared is A squared minus C squared. So B squared is 5 squared minus 3 squared, which is 25 minus 9, or 16. That means B equals 4. So now we can write the equation of our ellipse. We just plug in the appropriate numbers in the appropriate places and then finish graphing. So we have x squared over A is 5, but we need A squared, so that's 25, plus y squared over B is 4, but we put over B squared, so that's 16, and that equals 1. Now if we go back to our graph, the only thing we're missing is our 2 points on our minor axis, and remember we find that by using B. So starting at the center, we go up 4 on the minor axis, and down 4 on the minor axis. because that's the way it works. Then you just have to try and make an oval going through these points. I'm usually pretty bad at that, but do your best. And there is our ellipse. Okay, let's try one more of these. This time they've given us the equation and they want us to figure out all the points so that we can graph it. So the first thing to notice here is we have x squared over 16 and y squared over 8. So we know then that since 16 is bigger than 8, that the major axis is the x-axis. And that's because the 16 is under the x. That means that a squared is 16, so a is 4. That means our vertices are at 4, 0, and negative 4, 0. Because we're only doing ellipses whose center is at the origin. And remember, A tells us how far along the major axis we go to get our vertices. So if we go 4 and negative 4, 4 in either direction along the major axis, that's how we get our vertices. So we'll label these V1 and V2. Okay. Now we need to find the foci. So we know that b squared equals a squared minus c squared. We don't know c squared. We only know a squared and b squared, because the 16 is our a squared and the 8 is our b squared. But we can still use this information to solve for c. So b squared is 8, a squared is 16, and then we still have the minus c squared. So let's solve for c squared. If we subtract 16 from both sides, we end up with negative 8 equals negative c squared. We don't want the negatives, so essentially we can divide both sides by negative 1. So we get 8 equals c squared. Then we have to take the square root of both sides, and we get the square root of 8, and technically it's plus minus, but we're really talking about distances here, so just plus is c. Break down the square root of 8, that is 2 square root of 2 is our c. So I don't really know where to put that, so I'm just going to throw that in the calculator and get a decimal approximation, only so we can graph it. So 2 square root of 2 is approximately 2.83. So remember, the foci also go on the major axis, so we need to go about 2.83 to either side of the center. So one of those is about right here, and one of those is about right there. Let me move my labeling so it looks right. So this is our V2, this is our that's V1. Yikes. V1 and F1, and this is our F2. We can also find our 2 points on the minor axis because we know that B tells us where those points are. So we know that B squared is 8, which means B is the square root of 8, which happens to be the same thing as C this time. So that's 2 square root of 2, or approximately 2.83 on the minor axis. So we have a point about here and a point about there. And now we can attempt to draw our oval, which again, I'm terrible at drawing these ovals. Do the best you can on your paper. In Pearson, obviously, it will be easier. Okay, so how did we determine again which axis was the major axis? Well, we said that up here. It was because the 16 was bigger than the 8. So that means the major axis is the x-axis. So I'm just going to write C above, highlighted in blue. And this color blue, just to make sure. And that is right here. Okay, in the next video, we will do some more examples.